In 1912, French chemist Louis-Camille Maillard attempted to reproduce biological protein synthesis in a lab. Instead, he discovered the most important chemical reaction in the culinary world. It is the reason a seared steak tastes different than boiled meat, why toast tastes different than bread, and why roasted coffee beans smell the way they do. It is not merely burning or caramelization. It is a complex cascade of chemical rearrangement known generally as non-enzymatic browning. The Maillard reaction is highly specific. It requires three variables: a reducing sugar, an amino acid, and thermal energy. It is distinct from caramelization, which is the pyrolysis of sugar alone. In the Maillard reaction, when the surface temperature of food exceeds roughly 140 degrees, the carbonyl group of the sugar reacts chemically with the amino group of the amino acid. This releases a water molecule and forms an unstable intermediate structure known as a Schiff base. The unstable Schiff base undergoes a reorganization of its atoms to form a more stable structure called an Amadori product, or a Haynes product. At this stage, the food has not yet visibly turned brown, and the characteristic flavor has not significantly changed. This is the silent phase of the reaction, where chemical potential energy is building within the food matrix. As heat continues to be applied, the Amadori products degrade and react further. This is where the reaction branches exponentially into hundreds of different pathways, producing thousands of new flavor and aroma compounds that did not exist in the raw ingredients. Furanones generate sweet caramel-like notes. Pyrazines create the savory, roasted, complex flavors found in seared meat and coffee. Theophanies provide roasted, meaty qualities. Simultaneously, these small molecules polymerize to form large, complex brown pigments called melanoidins, which create the visual crust. Water is the enemy of the Maillard reaction. Water boils at 100 degrees. Since the Maillard reaction requires temperatures above 100 degrees to proceed rapidly, any significant surface moisture on the food acts as a thermal barrier. The energy applied to the pan is consumed by phase change rather than chemical change. This is why patting meat dry before searing is not a stylistic culinary choice, but a chemical necessity. While the Maillard reaction creates flavor, pushing the reaction too far can produce a byproduct called acrylamide. This occurs specifically when the amino acid asparagine reacts with reducing sugars at very high temperatures. Acrylamide is classified as a probable human carcinogen. This creates a chemical sweet spot in cooking, generating enough heat to create pyrazines, but not so much heat or time that you accumulate excessive acrylamide. Cooking is effectively an edible chemistry experiment. The Maillard reaction is the manipulation of heat to break molecular bonds and forge new ones, turning raw biological matter into a complex sensory experience.